Alright, so this is like my favorite class almost of the year, okay?
Oh, what are your favorite?
No, not talking about, I'm talking about, sorry, favorite lesson,
Oh,
okay?
right.
One of my favorites. There's
This
still
is my
seven.
favorite class, though. Yeah,
Is it?
my
Is it?
first one. Yeah.
Okay, don't let the word out. Yeah, alright.
We're not yours.
You know you are. You know you are.
That's
Okay.
right.
So listen, Miss Hensoni gonna be giving you some information about dry ice, okay? And you wanna take, so there's some information that you have to get down, that's on your paper, on both sides, so you have a better understanding of kind of how it works. Oh, I'm talking, you're not. I know it's great you get to be with some other friends that you don't get to see all the time, but. Also, we're going to be sharing some extra information that might be good for you to put down because Ms. Sanzone and I will probably be asking you to kind of gather that information into a graphic organizer in the near future. So just a good idea to do that. My students, quickly, if you didn't finish or you weren't here, Pure Substances and Mixtures Review, that's officially due tomorrow because we're not going to go over today, obviously. Okay? And Jack, check in with me about your grades. Okay. I found it, but I have questions. Okay, so at the top of your paper, I want you to write that on the yellow plate, so write yellow plate, and you put an equal sign, is regular ice, so you can say H2O ice or regular ice. So that's gonna be on the yellow plate. And on the pink plate, I am going to put a piece of dry ice. So pink plate is dry ice, yellow plate is
Oh my god.
regular ice. And with scissors. Okay, and
The ice is bleeding.
how many of you have ever done anything at home with dry ice, or you've been to a party that where dry ice is present? Yeah.
So this video where like a hockey team threw on a bunch of dry ice onto the field, and they're not field ice,
That would be a rank.
and then they all like ran out. It was pretty cool. It was like those fog machines.
Oh, the dry. Oh no.
Yeah.
Oh, that is kind of cool. All right, so they're approximately about the same size, and I'm going to come around and just have you kind of observe. You're very used to like a regular ice cube, okay? But I want you to predict. I want you to think about and predict what these are going to look like by the end of class. What do you think what's going to look like on the plate? Okay, the regular ice in yellow, and the dry ice on the pink plate. Okay, so make a prediction. I'm going to come around. Do not touch, because what you're going to find out if you don't already know is that dry ice, it's actually kind of like an oxymoron. It's so cold that it can burn you. Okay, that is true. And we'll talk about what temperature it gets to be in a minute. Let's make some observations. Make a prediction. What do you think is going to happen by the end of class?
Why is it like
We're going to talk about that.
we get at least 50 dozen a week? No, we got 6 doubles. Yeah. 7. Bro, we got 8. No, well, Harry got 7. Yo, Harry. No.
So it's okay to touch the bottom of the plate, but you can't touch the dry ice. We don't even do that.
He's right.
I can interrogate you. Where were you on the night of November 6th? Okay. Huh?
I was with my dad.
Oh, really?
Yeah.
some predictions to share. Let's get a few predictions. Allie. Okay, someone else is talking, so you listen.
Well, my prediction was that by the end of class, the regular ice would have melted, but the dry ice would stay the same as it is now.
Okay, so melt, stay the same. Other or similar predictions? Helen?
Well, the dry ice might get like smaller, or it would either just be gone, or it would sublimate.
Okay, so smaller or gone. All right, yeah, what's your name?
Harrison.
All right, Harrison, what do you think?
I think it would turn into a gas, possibly.
Okay, all right, awesome. What do you think is going to happen to the regular ice?
Melt.
Melt? Other predictions, similar? All right, so we're going to kind of keep these here, and we'll go back and we can kind of see what's happening during class. We'll go back at the end of class, okay, and see how it ended up, all right? Okay, so on your paper, we want to make sure we get some information about, you know, what dry ice is. And does anyone know it's frozen what? Who knows what it is? Kenny? It's frozen carbon dioxide. So that's the first blanks. Okay, so fill in your paper. And you probably know what the next fill-in is. It is a gas that we what during breathing? Ryan? Exhale. Okay, and the gas that what use in photosynthesis? You know this. Name? Stella. Plants, absolutely. You guys know a lot about photosynthesis. All right. Shh. So, and this has a little extra piece of information there. It says, along with water vapor and sulfuric acid, carbon dioxide is given off before, during, and after volcanic eruption. Okay. It's also the same gas that is added to water to make soda. Okay, soda water. Yep. So temperature. First of all, it says, what is the temperature of frozen carbon dioxide? You're going to notice parentheses there. What I want you to write is the chemical formula. What is the chemical formula for carbon dioxide? What's your name?
CO2.
Your name is CO2? No. Okay, so CO2 is correct. All right, and what else? What do we call this when we have two elements that are next to each other that are chemically combined? What do we call that?
Compound.
A compound. Excellent. Is a compound a pure substance? Yes or no? Yes. Compound elements and compounds are pure substances. And again, we in class, as far as classes, we might be in different places or what we remember. I know my class, we're just kind of starting to go over elements, compounds, and mixtures. I know you guys have done some things with mixtures, some other things with elements and compounds. All right, what do we call this two here? Actually, you might see it even on your computer when you're going to put it. Yeah, subscript. This is called a subscript. When the number is up high, like an exponent, what do we call that? Yeah, you heard it. A superscript. Okay. So as we get into chemistry more, and you guys are working with these formulas, you have to remember that that's the proper way to put it. It's a subscript. How many atoms are in this compound? Ryan? Oh. Three. How do you know?
There's 2 atoms of oxygen and 1 carbon.
Right. So when we don't see something written there, we automatically know that it's 1. Okay. So 1 atom of carbon, 2 atoms of oxygen. Excellent. Okay. So let's get to the actual temperature. So 78.5 degrees Celsius, and I know it's hard to still kind of wrap our head around what is Celsius and compared to Fahrenheit. So compared to Fahrenheit, that is negative 109.3 degrees Fahrenheit. Negative 109. Which is why I say it's so cold that it can burn you, because it is so cold that after you have it on your skin, it's going to start eating away at your skin and cause you to have a burn. Okay? Which is why we can't touch it, which is why I have protective gloves. Okay? So after like a few seconds of touching it, that will start happening. All right. Next. So down below it talks about what are some of the uses. You can take a look at how dry ice is used. Some other properties. What are some properties that we know about like regular ice? Kenny? Okay, so it can go from a solid to a liquid, so it's a solid. That's a property, the phase of matter that's in. Okay. Yep. It's cold. Okay, it's cold, right? What does water freeze at? 0 degrees Celsius, or what Fahrenheit? 32 degrees. Okay, so look at that difference between regular ice and dry ice. Who remembers what I said that the density of water is? 1 gram per cubic centimeter. Dry ice is let me check, 0.92. Yeah. Dry ice, the density of dry ice is 0.92 grams per cubic centimeter. Okay, whereas regular ice is 1 gram per cubic centimeter. Someone just remind me, what does this actually mean? When I'm talking about gram per cubic centimeter, we're talking about density. How can you explain this? How can you kind of explain that scientifically? Oh, I messed up. Yep, my bad. Okay, yep, I totally messed up. So, wait a minute. This is regular ice. This is water. Okay, frozen carbon dioxide is 1.5.
1.5, yeah.
Okay, thank you. That makes a lot more sense. Okay, so when I mean regular, I'm talking about regular ice. So regular ice, and then when it's melted, water, 1 gram per cubic centimeter, and frozen carbon dioxide is 1.5. What does density mean? Yeah.
It means how closely the atoms are packed together.
Right, exactly. So, and we're talking about grams per cubic centimeter. So we're talking about mass and volume. How much matter is in a certain amount of space. Okay. One cool thing that Ms. Anzone and I will talk about this year, not for today, but we know that water is 1 gram per cubic centimeter, which is a liquid. But look at this, ice is a solid, and its density is less than. So yeah, that kind of leads to a good conversation. Why would that be? So we'll talk about that in the future, but it's kind of like, yeah, wait a minute, solid, that'd be different. All right, turn over to the back side. We're gonna get going on some experiments that you guys are here for. Okay.
I thought we were here to learn about how to
Learn about what?
the name of it.
Yeah.
It's snowing. I keep saying that.
Are we allowed to?
No, not a good idea.
So it's carbon dioxide.
Tony, you're gonna get Mario.
So I could probably pass out.
Yeah, we don't need any of that. Okay, so
That would kind of stink.
you're adding hot water. All right, so listen. Don't be so. Listen, the fog is something that you can touch. That's okay. And we are actually, can we open the door for ventilation? So I'm not. The dry ice is down here. Okay, so that can't get to you. All right, but it's actually cool if you kind of pour it over your hair, like.
Pour it over my hair.
I'll come around. If I accidentally dump on anyone, Adrian, it'd be you. Johnny's fluffy hair, get it in there. Oh, that's boiling hot water. You okay with this? Can I put up your hair or not? All right, there we go. All right, so listen, we're getting less. I'm going to come around to everyone else, but I got to kind of resupply because I put boiling water in there. All right, and what's happening? Yeah, this is already really cooling down. We see that we have, less of the fog. By the way, where do you notice the fog is going?
Up, down, up, down.
Well, it's coming up through here because that's where it needs to exit, right? It's like, want to find a place to go. All right, but then here. So tell me about this fog compared to the air around us.
Oh, it's
No. What's your name?
Skylar.
Skylar.
It has, I think it has like more liquid than what the air does, so it's heavier than.
Okay, so there's definitely some moisture. You got some water vapor in there. Okay. We also know, though, with the water cycle, that we get that evaporation that happens in the clouds, and then it gets heavy where it kind of comes down. So there's still some moisture in our air, but that's a good thought. Keep going. Bridget.
The fog is more dense than the air.
Yes. The fog is more dense than the surrounding air, which is why it's falling down. Okay. So we're gonna get some more pieces in there. Well, I'll come around to some extra people. So this is why. So listen, when we're talking about like volcanoes, and that this is something that is carbon dioxide is something that is produced. So some people during like a volcanic eruption, there's a pretty good production of carbon dioxide, and some people think if they get low that they're going to kind of protect themselves, but what you don't realize is some people will die just from the carbon, because the carbon dioxide goes low to the ground. So people that are kind of going low and trying to hide, sometimes that's what they might, die from is the overexposure of carbon dioxide. We have about 0.035% of carbon dioxide in our atmosphere, naturally found in our atmosphere. 0.035% is carbon dioxide. Okay? If we get up to even 0.5%, that is extremely unhealthy and dangerous. This is why, and CO2 is considered a what? A all right, let's try this again. Oh my God! That's spinning out of me. Wait, let's get Miss in zone.
I might use that next Halloween.
Everybody has I should have told her I don't want to get the way to get it feel is to get
Again, everybody? You really had to put any on? No. Alright. So again, this actually feels cool now, whereas boiling before, it's just cooled it right down. You can see the difference. Alright. So listen, I'm pouring just the liquid down the sink because if the dry ice goes down the sink, it could freeze the pipes. That would not be good. I'd probably get in trouble.
You sure?
Alright. Now.
Was there already brown stuff in that
It was
graduate
kinda like
cylinder?
rusty, yeah.
Oh, okay, all right.
So I have had students in the past, can you put a glow stick in it or food coloring? I've tried all that. It's not like the color comes out with the fog. So it's not, it just kind of sits there. So it's not as exciting. I think it's going to be like this colored fog now. No.
Oh, that would be so cool. That would be good.
I know. All right. Hey, did we fill in the first on the back side? No. So the fog, and Skylar kind of hit upon that. The cloud or fog that dry ice makes when immersed in hot water is a combination of carbon dioxide and water vapor. Carbon dioxide and water vapor. Okay, and we can also answer the next question. Why does the mixture fall toward the ground and not go up into the air? Okay. So more, let's use science terms. So saying heavier, let's say more dense. More dense, than the surrounding air. More dense than the surrounding air.
Wait, so like, if the air was like all that, would it not like fall down?
Right.
It
So-
is more dense than
So if it was similar, it would kind of hover, and if it was lighter, go up. So we think about helium. One reason we use helium for balloons is because it's lighter than the surrounding air. Okay, it's one of the lightest elements. All right, so you should have the first two things filled in on the back. Help a neighbor out if you notice they don't have it filled in. Any questions? All right, so the next thing, actually I'm going to try, so this might bother some people because of the sound it makes. Now, you guys are not the generation of hearing fingernails on a chalkboard. But, so I'm heating up this metal spoon,
Please stop talking in the back.
and I'm going to put it,
Stop talking.
called the screaming.
It sounds like drinking a pork on a plate
Yes, yes.
or fingernail.
Okay, so it's just vibrating. The reason it's vibrating so quickly that it's producing those kind of sound waves. All right, so that's the screaming. All right. So this next thing, listen. This next thing, you're gonna actually be able to kind of interact. So in a few minutes, what I'm gonna have you do is you're going to formulate a line somehow. You might formulate a line over here, come around, and go back and sit down. Okay? I'm going to be adding some dish soap. Oh no. Alright. So I'm going to add the hot water, again, which is, as we know, we still see a fog that's coming from there. But again, that boiling water, when it touches it, that temperature kind of creates that fog a little more intensely. Alright, so I'm going to add the hot water, then I'm going to add some soap. Okay, when I have you line up, you're going to, again, the dry ice is here. It doesn't come up here. There is something else that's going to be coming up. Can anyone predict what's going to happen?
So squirts up on top and falls over the side.
Okay, so bubbles are gonna form. What do you think is gonna be inside the bubbles? Yeah. So it's gonna trap the carbon dioxide and water vapor together. Pretty cool. So what you're gonna do is you're gonna kind of grab some. Some of it's gonna come off the side. Shh, shh, shh. Some of it's gonna come off the top. You're gonna just take some and go. Okay. So you can kind of keep them. You can pop them. Excuse me. No, you're not eating them, and you're not getting obnoxious and like shoving them in people's faces. Okay, so you can just kind of hold it and pop it. All right, so actually, let's start. These first two rows line up. Yeah, put your clipboards down. Hold on. No. I meant these two this side. You guys can come up and line up. Try to do row by row to line up. Now you're
I want to go see. Excuse me.
Okay, so don't knock it over. Take some at the bottom. Go. Take some and go. Take some and go. Take some and go. I'm going to have to read. Take some and go. Yes. Oh my God.
I feel it.
Take some and go.
Oh, it doesn't feel that weird, actually.
Just farted.
Mine's already gone.
I don't want to. You guys ready?
So cool, huh? Hey, Johnny. Sit down. Johnny,
So there's some paper towels.
I'm gonna pass those around.
You guys need paper towels.
I've already wiped it on my pants.
Really? Yeah.
I'm so happy. Hey guys, go sit down. Go sit down.
They're popping.
You look so happy.
Yo, no, it's popping. David, put it in your hair.
There's paper towels around. There's some right here. All right, so. Okay, so we need to fill in the next answer, the next question here.
Oh no, we got some soap on it.
Okay, so Why did the addition of soap to graduate cylinder change the outcome? We actually talked about this at the beginning. Okay, that the soap in the water traps the CO2 in the water vapor in the form of a bubble. Okay, so the soap in the water trapped the CO2 and water vapor
That's the best sound ever.
in the form of a bubble. This is what a science lab, this is what the kids think of when they
Should be,
think of what it
yeah.
sounds like and looks like, right? I should have brought my white crazy wig and,
She doesn't like Halloween.
She
well,
she had
one
a Halloween
tried, yeah.
party when the girls were little.
Oh, yeah. Yep,
That was
that's
really-
right, I had
yeah,
some of this,
yeah,
yep.
It was so fun. They were amazed. They were like, we need to go to the Lathrop's house again.
My sink of,
That's so cool.
Water coming out.
well, there's a little bit of water and then there's,
And Narnia.
yeah. Okay, so let me repeat that again, guys. Shh. Remember, help a neighbor out if they didn't get it down. Rachel, I don't see you writing and I need to. Yeah, but I don't see you writing. Is she writing for you? Oh, no, she can do it herself. No, she can do it herself. All right. Shh. So, remember that, okay, the soap, okay, and the water trapped the CO2 and water vapor in the form of a bubble. All right, Nicole, how many of you were able to hold the bubble for a while before it popped? And then there's those annoying classmates that pop yours.
Yeah. Shelby.
Shelby.
I was walking to my seat and she was like that.
All right. Okay, next.
That was Ginny's final resting place.
What?
It was Ginny's final resting place.
I know. Or you can hear it vibrating against the.
We should put saran wrap in there and watch it like the gas like pop it. And then all
Have you seen that?
That looks like the nice
Yeah, we should put a lid on it here.
and watch it like the
Well, we'll talk about that in a sec. All right. Okay, now this might be a little bit hard to see. Usually, if it's just my class, I have people kind of stand around, but we might be able to see because of how high it is. Okay, so predictions. I'm going to try to blow bubbles into the tank. What do you think is going to happen? Adrian?
It's gonna reject it.
What do you mean?
Like, push it back out.
Why do you think that?
Because the carbon dioxide condenses in
I
the
mean,
air in the bubble.
okay. All right. Any other predictions? Let's see if it's going to reject. Now, it might take me a few times. I have to kind of do it.
Where's your school? No, that's terrible.
Do you want to see it? Do you want to see it? If you're going to stand up and look around, that's okay.
Guys, you got everything.
Oh, yeah. Oh, that one popped.
Pop balloon.
You can stand on a stool up here.
Yeah. Johnny's too small.
I'm asking how to try this.
So we got some dancing bubbles.
Oh, it fell.
You guys see it bouncing?
Oh, it's stuck.
So in the back, you're coming forward so that you can see what's going on and that you're a part of class.
You guys want to come around this way?
I'm too short, stop.
Well, some sometimes you just need to blow some bubbles. You
Right.
know?
Right.
Right?
Right.
And so, you know, on a stressful day, the slates might need to pull these out, you know, after having Johnny in class. You know. Like I just. All right. So, bottom line, again, the air that the gases that are in the bubble are less dense, okay, than the carbon dioxide gas. All right, which is why they end up being rejected, which is sad. I say they're dancing bubbles. I think that makes it more happy.
It's a glass half full
Right.
perspective.
Yeah.
Oh, so are you exhaling carbon dioxide?
And oxygen.
Oh, because it's.
Oh, there we go. Okay, all right. Now, next experiment here. And you guys can stay there. Now this one I have gotten better at. But I don't know. Oh, I don't.
It's pretty cold over here.
No, it was a one where he was fighting.
Oh, well. Making sure she's safe. Make sure you're safe.
You would save me, wouldn't you? Oh boy.
It's that one.
Actually, I think
All right.
I've got a YouTube video with you.
What am I doing, Kenny? What do you think I'm gonna do?
You're gonna make a big bubble with this string.
How am I gonna do that?
It's gonna be like your pet, and then it's gonna become a big bubble. You'll see.
She got that on camera.
This is evidence for the trial that'll be.
You're telling me to move my
All right, so I'm gonna.
You should make a tornado.
And how do you propose? I do?
You go like this.
Oh, yeah. All right. We'll see. Now you have to get a complete seal. I don't know if this is the right.
Oh, you showed
So
me
you can
this
see like a film.
Oh yeah.
Me too.
Listen, don't breathe in it.
David, I dare you to walk.
Cooper.
I didn't know it was gonna fall. I had to breathe. I had to. That was all. I didn't know that was gonna happen.
Was it actually good?
Don't breathe in it.
I'm
trying to accomplish?
I won't breathe.
Now she's not gonna be able to get it again.
Don't breathe.
I'm sorry. Somebody get an air cannon and shoot it. Go slower.
It doesn't matter. We're gonna blame it on you anyway.
We would have had the first one if it wasn't for you. Alright, though, they got it.
Well, not on me.
We'll try the other way. All right.
I'm not blaming it on me. I did nothing.
It was probably harder to go the opposite way.
You gotta make it so it's good.
I know. It's too. Yeah.
Yeah, it's too rigid.
Come on, Cooper. Yeah,
I'll
try. Cooper, stop. Cooper, stop.
Actually, students usually do better than I do. So I'm just getting a little more hot water. Soap on it? No, it should be okay.
actually satisfying though.
It is.
Unbelievably satisfying foods.
Try it in a bowl
Try it.
instead.
What?
I didn't do it. That was close. Like you, David.
Go ahead, it's right in there. You know what? Add a couple more squares of soap.
Can you go like the other way? Or that
Can I go next?
Like
Oh, like
this
the long
way?
way? She could try that if the string is long enough. That's up to her.
Well,
Yeah, you should try it.
Yeah, you should try
You should
it.
definitely try it next
Yeah,
time.
you should try it.
How many people go Stella? How many
You
people do that
definitely shouldn't
too?
do that next
Like
time.
everyone, when I first meet them
Yeah.
and I tell them my name, that happens all the time.
I wonder if
Don't.
most
They
people
probably
probably don't
don't,
know
yeah,
what
most
the
generation
reference
probably
is.
doesn't.
Yeah.
Wait, do I need to put more
Go,
soap
David.
on the rim?
No, I don't think so.
This is
David.
don't do it, David.
Oh my god.
David, don't.
Good
David.
thought.
Ladies and gentlemen,
You
don't break it. See, it wasn't me the whole time. It was him.
Back away.
David, back.
Ladies
No.
and gentlemen, we got him.
No.
It looks like an old TV though. But you're
It does. Yeah, you're right.
Okay, so actually let's talk about this. Why is it rising up?
Because the carbon
Because why rhymes?
dioxide is rising.
Okay, but talk to me about gases and
The carbon dioxide is like filling up and has to have a place
okay, let's keep going. Stella.
Is it because the carbon dioxide is dense? Now it has nowhere else to go, so it's
Okay.
expanding up into the bone.
Okay, good. Now, who just heard that? Hey, too much talking. Okay, so what do we know about gases when they're inside like a closed container? Because right now, the gas is closed inside here.
Well, there's still more of it being
Excuse me.
made, and it's filling it up, and it's trying to escape because there's not enough room for all of it, so it's lifting up.
Right, and how do the gas molecules act? How do gas molecules act? They're kind of crazy. They're like, woo! Okay, all over the place. And so they want to find a place to escape, right? So eventually, and again, that's why I was adding more hot water because I wanted more in there to be able to try to kind of get it.
Expanding.
Yeah. Nice job. It's awesome.
Don't pop it.
That was pretty good
Let's see
stuff.
how long it gets.
That was good. That's okay. They're pretty good. That was pretty good.
Can I do it? Can I
All right, back to your seat. Yes. Oh my God.
Hey, this is the best thing ever, by the way.
It is. It's so much fun. They love it. It's like,
Yeah, thank you so much. Okay, Carrie and Harrison, can you sit down? Get down, please. Just find a seat.
How do I get down?
Step down. There you go.
everyone has a personal. Whose is this? Stella, is this yours? Yeah. Okay. All right. Okay, so on your paper. Now mine's soaking wet. Oh, actually, let's skip to the last one. Oh, actually, no. Let's do the next one. So, I'm going to kind of walk around here with the dry ice and the regular ice cube. Remember, regular ice cube is on the yellow plate. Dry ice on the pink plate. And you'll notice there's actually kind of like frost on the other bottom side of the plate. Don't touch it this time. Some people, I said you could touch the bottom of the plate the first time. It hadn't really created the frost yet. It's not a good idea to touch that now. Okay, so write down what you observed in that third space. What happened? Yep. The third one down. Yep.
Hi,
The teacher's next class.
I just wanted to do it because I'm
scared to just play console.
I'm gonna go back. I'm gonna go buy a dryer. I am gonna try. Sam, what's the next one?
So, what did we write? What did you guys write down for that third question? Shelby, what did you write down?
I said the regular ice cube melted while the dry ice barely melted.
Okay, so I agree with your first statement. Okay, that the regular ice, no, it's fine, that the regular ice melted. Okay, so it went from what state of matter to what state of matter? Solid to liquid. Okay, so that means something melting going from solid to liquid. How are the atoms and molecules behaving when it's going from a solid to a liquid? This is kind of a recap. Solid to a liquid, how are the particles, how are the atoms and molecules acting? Johnny?
They're going nuts. Well, they start off kind of like with the solid, and then like you pour the boiling water and like, wow, and then they, yes.
Okay, I'm talking about regular ice, solid to a liquid.
Okay. It's so they're really,
I'm sorry, hold on.
Yeah.
We have people in the back that are being rude.
Stop talking.
so we're.
Sorry, hold on. Rachel, zip it or get moved. You too, David. I learned your name real fast.
very fun.
Okay, so can we try it again, Johnny?
So I'm just gonna be melting this time.
Yes.
So it's like when they're solid, they're kind of vibrating close together,
Good.
not going everywhere. And then as the heat gets added, they're like, oh, let's turn into a liquid. And then they
What's the science name for heat?
thermal energy.
Good. Okay, so as thermal energy, yep. So,
They spread out.
okay, then they start spreading out. Awesome.
They're going a little bit crazy, but not really crazy.
Yeah, remember they're able to kind of flow more freely past each other. They're still attracted to each other, but they're just a little bit able to freely flow. Okay. Okay, so the dry ice. Dry ice. So Shelby, not to go, but you had said it wasn't melted, or okay. So who remembers the term, or who knows the term? Because it is going directly from a solid to a gas, skipping the liquid phase altogether. Jack.
Sublimation.
Excellent. Sublimation. All right. So that's, you want to write down that the regular ice is melting, goes from a solid to a liquid, but that the CO2, the dry ice, is going from a solid to a gas, which is known as sublimation. I'll write that on the board. Sublimation.
CO2 is going to sublimation.
Okay, so solid directly to a gas. It skips the liquid phase altogether. Doesn't happen. Who remembers the opposite, or who knows about the opposite of sublimation? So sublimation is a term you need to know as 8th grade. The other term, going from a gas to a solid, you don't have to know. I don't know why. Yeah, you remember, Helen? Deposition. You go from a gas to a solid, so that's like frost. Okay. All right, so why did this happen? I kind of explained it so this is the part where you want to write that it skips the liquid phase. This is how dry ice gets its name, because it doesn't go through a liquid phase. That's why it's called dry ice. Okay, it doesn't go through a liquid phase. Okay, skips liquid stage altogether. And dry ice weighs twice as much as regular ice. So we talk about density, I'm talking about the weight. Okay, weighs twice as much. So make sure in that last one, you're explaining that dry ice, the reason that this happens is because it skips the liquid phase. And that's why it's called dry ice. All right, by the way, so people are like, where do you get dry ice? There's actually places you can get it. There's a place in Dover called Airgas, and they have specialty gases. Like when I went there this morning, up at 7:30, they were loading trucks to be able to get gases to hospitals. That's kind of like their big thing is getting, gases that are needed to hospitals. So, and then they usually have a big supply of dry ice around Halloween because teachers do this. People want it for effects and everything. I was telling someone up back that, sometimes people put it, like at Halloween parties, they'll put it in their punch. And as long as you're getting the top layer and you're not scooping up the actual dry ice, you're fine. You can drink it. That's okay. Because it just makes it kind of, bubbly, and it just kind of smokes and just kind of gives that effect. All right? It's really cool. Some people put it in their pumpkin, so you just get a little dish. The only thing is you kind of have to replenish it a lot because you get a little dish and you put the dry ice in it and you put the hot water. Okay, but we see how quickly it kind of goes, so it has to be kind of replenished. But it's fun for, again, effect. Kind of smoky effect. Yeah, it's so smoky. All right, so I gotta get cleaned up for next class. What do you guys think?
What did we say, Mrs. Lathrop?
Thank you.